this application example, we are given an acceleration function and we want to find the corresponding position function. We are told that a particle is moving with the given data, and we want to find the position s of t of the particle. The data that we're given is that the acceleration at time t is 12 sine t plus 3 cosine t, and then the position at 0 is 0, and the position at 2 pi is 10. To find the position function, we first need to find the velocity function because the velocity is the antiderivative or the integral of the acceleration. And then we can find the position function s of t because it's the antiderivative or integral of our velocity function. Let's start by writing down our acceleration function. A of t is equal to 12 sine t plus 3 cosine t. And now we can find our velocity. It is the antiderivative of the acceleration, so that's 12. And the antiderivative of sine t is minus cosine t plus 3 times the antiderivative of cosine, and that's equal to sine t. And then we can't forget to add on a constant. Whenever you take an antiderivative or an indefinite integral, you have to add on that constant. Let's go ahead and let's rewrite this before we take another antiderivative. This is minus 12 cosine t plus 3 sine t plus c. Now we can find our position function. It is the antiderivative or integral of the velocity. This gives us minus 12. The antiderivative of cosine t is sine t plus 3 times the antiderivative of sine t, which is minus cosine t. And then with our constant, we multiply that by t, and then we have to add on a second constant, which we're going to call d. Instead of c and d, you could also use c1 and c2. Now what we need to do is find what c is equal to and what d is equal to. And to do that, we are going to use that we were given originally back up top here, that s of 0 is 0 and s at 2 pi is 10. Let's first let t be equal to 0. So s at 0 is going to be minus 12 times sine 0 minus 3 times cosine 0 plus c times 0 plus d. Now let's see what this is equal to. Sine of 0 is 0. Cosine 0 is 1. So this is just minus 3 plus d. And that is equal to 0, what we were given originally. So this tells us that d is equal to 3. And let's highlight that so we won't forget it. And now let's find s at 2 pi. S at 2 pi. Let me highlight that we're going back up to that line to find s at 2 pi. It is equal to minus 12 times sine of 2 pi minus 3 times cosine 2 pi plus c times 2 pi plus d, and we can go ahead and add in that d is 3, so that gives us a plus 3. Now let's see what this is equal to. Sine of 2 pi is 0, cosine of 2 pi is 1, so this is minus 3 plus 2 pi c plus 3, and that is equal to 10. The minus 3 and the 3 cancel, so we get that c is equal to 10 divided by 2 pi, which is just 5 over pi. And we'll highlight that. Now all we have to do is just substitute in c and d into this equation right here. This gives us s at t, that's our position function, is minus 12 sine t minus 3 cosine t plus 5 over pi times t plus d, which is 3. And there's our final answer. Remember, with these types of problems, you can always check your answer by taking two derivatives of the position function. That will give you the acceleration, and that will tell you if your answer is correct. And that's it.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.